In the first video for the unit, we learned triangle given, you're given one of the angles at 28 degrees, which find the second angle. We know that in a right triangle, the acute angles have to add up to be 90 degrees. So if I subtract the angle I know from 90, we're going to get our angle B measure, which is going to come out as 62 degrees. So I found one of the three things that's missing. The next thing we're going to do is we're going to label our sides here, opposite, hypotenuse, and adjacent. So you set up a ratio with the variable in the we're going to use a trig ratio, or you could use Pythagorean theorem. Since you know now two of the sides, we can always use a squared plus b squared equals c squared to find the third side. So I'm just going to use another trig ratio because I think it's easier. So anytime your variable's in the denominator like this, we're going to divide. So 15 divide by cosine of 28. And this is going to come out approximately. So use trig ratios to find missing angle measures in a triangle. So on all of your calculators, there are buttons that say these three things. The first three I listed, sine, cosine, and tangent. Those are the angle measures. Multiple choice problem. I know that I'm going to use one of the inverse ratios in order to figure out what the missing angle measure is. Now, same thing goes for secant, cosecant, and cotangent. You can use those to find side lengths. You can use cosecant inverse, secant inverse, and cotangent inverse to find angle measures, just like sine inverse, cosine inverse, and tangent inverse. So I'm going to circle my angle, looking for theta here. So the two sides I'm given are the adjacent side and the hypotenuse. So that's going to lead me to use a cosine ratio. So we're going to say that cosine of theta is equal to the ratio of 6 over 11. In order to figure out what theta is, I'm now going to say that I'm going to take the cosine inverse of that ratio, and that's going to give me what my theta value is. So in the calculator, taking cosine inverse of 6 over 11, I get 56.9. And looking at all of our answer choices, that would be letter C. Moving down, three problems, they all ask us to solve the triangle. So in number 4, if you notice, all you're given is 2 of the side lengths. So the easiest thing to find is always going to be your missing third side. Easiest done by doing Pythagorean theorem. So I'm going to doing that, 8 squared and 10 squared together is 164. And if I take that square root, we end up with 12.8. I'd still have to find the so so that's again considered solving the triangle because I've found all three missing pieces. So we're going to skip number 5 and go over to number 6. Very similar problem. I'm missing this third side, so I'm going to find it using the Pythagorean theorem. Okay. A total of 106. So I'm going to take the square root of that and get approximately 10.3. So there's one. This time I'm going to select angle B. I'm given the opposite and adjacent sides. So again, just like number 4, I'm going to use a tangent ratio. So we're going to do tan of B is equal to opposite over adjacent, so 9 over 5. Again, I'm finding an angle measure, so this is where I'm going to use my inverse. So tan inverse of 9 over 5. Nine over 5, I get approximately 60.9. Again, always add. So I'm just 90 degrees. And we would end up with 29.1 degrees. So type problems. So it says a ramp has a length of 20 feet and a vertical rise of 2.5 feet. Find the ramp's horizontal distance and the measure of the ramp angle. We're going to delete this last sentence because we didn't specify. Got to find x, got to find theta. Finding x is very easy. It's just Pythagorean theorem. Okay, so let's do a little math. If you subtract 20 squared and 2.5 squared, we get 393.75. And if we take the square root of that, we get a horizontal distance of 19.8 feet. The other thing that the problem asks for is the ramp angle. So if I'm looking for theta, I would a sine ratio. Sine of theta is equal to 2.5 over 20. Again, we're finding an angle, so we're going to have to use one of our inverses. So sine inverse of that ratio, and that will give us our ramp angle. I get approximately 7.2 degrees. Okay, next is at a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees. So here's your 200 feet. It says angle of elevation from the bottom to the bottom is the 35 degrees. So this angle right here is 35. Then it says the angle of elevation to the top is 53. So angle of elevation to the top. So the 53 is the entire angle. So blue would be the 35 and purple would be the 53. It says find the height of the smokestack. So what we're going to do first is we're going to find the height of the entire thing together, smokestack and building. Then we can find just the height of the building and subtract the two. So first we're going to worry about finding the entire length. So this entire height, which I'm just going to call x. So we're going to use a tangent ratio because the x is the opposite side and the 200 would be the adjacent side. So the angle of elevation to the top is the 53 degrees. So we're going to do tan of 53 degrees is equal to x over 200. Since the 200, or the x is in the numerator, we're going to multiply. So 200 tan of 53. And I get the figured out what the height of the entire thing is together. Now we're going to worry about just finding the building. They have it labeled as A, so I'm going to use A. Again, we're going to use a tangent ratio. This time, though, we're only going to do it to the top of the building, so that's a 35-degree angle. And that's still going to be A over 200. Just like the last one, the A is in the numerator, so I'm going to multiply. I get 140.0. Stack is the difference between the building and the entire length. All we're going to do subtract those. My smokestack height is 125.4 feet. Moving down. This unit, compass bearings. So compass bearings are going to be given to you with a degree measure and then two cardinal directions. So your southeast, west. Every time you're given a compass bearing, it's going to look like this. The first letter is always going to be north or south. Always be east-west, and that's going to tell you what direction you're moving from north or south. So the first one here is at south 35 degrees east. So starting from south, we're going to go 35 degrees to the east. The next one, north 80 west, we're starting from the north and we're moving to the west. Starting from the north, moving to the east. So if I gave you south 42 degrees west, we would start from south and we would move 42 degrees to the west. So that's where the angle in your picture would come from. So in our problem down here, I apologize for the picture. It's not the easiest picture in the world to read, but hopefully watching this video, you'll be able to see the picture a little bit easier. So it says a ship leaves port at noon, heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west, as shown in the figure. So notice from direct north that 54 degrees is that angle. It says find the ship's bearing and distance from the port of departure. So if I want the distance that the ship has traveled, I'm looking for C, so this purple distance. And then if I want its compass bearing, that means if I started at A and went directly there, what angle would I have to sail at? So the angle I'm looking for is this angle right here. Okay? So those are the things that we're trying to find. We're trying to find C, and we're trying to figure out that theta angle that I just labeled. That would be the compass bearing from the port to where the ship is now. So what can we do to figure that out? Well, there's a lot of lengths labeled on the picture, so let's talk about what we need to find. We're going to need to find D. We're going to need to find B. Because the overall picture is a large right triangle, so if I can figure out those lengths, then I can figure out what the distance from the port is by just using Pythagorean theorem. So here's how we're going to figure it out. This right here is a right angle, which means that if the top or the right-hand portion of this is 54 degrees, that means that the bottom portion down here has to be 54 or 90 minus 54. So if I subtract that 54 from 90 degrees, that angle in there has to be 36 degrees. Now, knowing that helps me because I know the hypotenuse of the triangle. This hypotenuse of the triangle is 20. And so I can use trig ratios to figure out what B and D both are. So that's what we're going to do first. We're going to find B and D. So from this 36, B is the opposite, D is the adjacent, 20 is the hypotenuse. So I'm going to use a sine ratio first. So sine of 36 is going to be B over 20. Since B is in the numerator, we are going to multiply to solve. So 20 sine of 36 is going to give me approximately 11.8. We're going to do another trig ratio. I'm going to use cosine this time to find letter D. So cosine of 36, D over 20, adjacent over hypotenuse. So we're going to do 20 times cosine of 36, and we get 16.2. So this side out here is 11.8. This side down here is 16.2. Now that's important because the overall triangle that I'm looking at, with the boat straight down and then all the way across to the port, is a big right triangle. So if we use Pythagorean theorem, we've got leg here is 11.8. We've got the entire leg on the bottom, which is the 16.2 plus the 40. So I've got 11.8 squared plus 56.2 squared. And that's going to give me my distance to port, which is C squared. So if we do the math, so adding those together and then taking the square root, we are 57.4 nautical miles from port. So that was one of the questions that got asked. How far are we from the port? So the next thing we have to figure out is what is this angle theta out here? And we're going to again use the overall right triangle to figure it out. And here's how we're going to figure it out. I need to figure out what this angle inside is. Let me highlight that a little better. I need to figure out what this angle is so that I can just subtract from 90 to find theta. So to find that angle in there that I just marked, all we're going to do is use a trig ratio. So of my overall triangle, this 11.8 is the opposite side, and this entire distance on the bottom is the adjacent side. So all I have to use is a tangent ratio. So it's exactly what we're going to do. We are going to say that the tan of x is equal to opposite over adjacent, so 11.8 over 56.2. In order to do this, we're going to again have to use an inverse tan ratio because we're finding an angle measure. So doing that in the calculator, we're going to end up with 11.9 degrees because we're going to do tan inverse. It comes out 11.85. So now that angle measure isn't actually this angle inside here. That's not the one I want. I want to figure out what theta is. So in order to figure out theta, we're going to subtract from 90 because this right here would make a 90-degree angle. So 90 minus 11.9 is going to give me a theta value of 78.1. So that's the angle that we're going to have to sail at. And what we would want to do is put the correct cardinal directions with that 78.1. So we're starting from due north, so I would put N first. And since we have to go to the left, that would be a direction of west. So my cardinal compass bearing would be more north 78.1 degrees to the west. If you have questions, make sure you make note of them so that you can ask in class next class. The compass bearings can be a little confusing sometimes, figuring out where they are in the picture. So if we need to talk a little bit more about that in class, we definitely can do that.